I've had some questions about match pairs designs, so I'm going to use some examples to break down what match pair design might look like within these contexts, and hopefully that'll help you understand match pairs design a little bit. So I'm starting out with this Frappy. You guys did this question, believe it or not, the other night for homework, but I'm going to talk about it in terms of a match pairs design. Now, within this, you'll notice that we have 166 adults from the St. Louis area are recruited and randomly assigned to receive one of two treatments for a sinus infection. Okay, so basically they're treating sinus infections when they talk about severity and whatnot. But what we're going to do is we're going to focus on these 166 people have the sinus infection. So we're going to scroll down here. All right, so you have 166 people with sinus infection. And you can treat that, and we're going to treat half with a placebo, half with, I believe it's amoxicillin, so we'll say half antibiotic. Here's how you can do this within the context of a match pairs design. Now, ultimately, they measure their recovery rate using, what's the term? It's up here somewhere. Next month they took the, sinonasal outcome test, I believe. One more time. Yep, sinonasal outcome test. Okay. And that's how they're going to measure, how well they did. Here's what you do with a match pairs design. What you do is you pair up your subjects so that they have some sort of similarities or they're almost identical. So say you wanted to do it in this case, right? You would have 88 pairs of people. And what you do is match them up based on some sort of similarity. Maybe it would be, let's see, match them up. We could do it under a lot of circumstances here. One of them I could do is based on the severity of their sinus infection. That'd probably be a good one. If you're able to measure that in some way, shape, or form. They mentioned that they had moderate, severe, or very severe. Pair them up so you have a moderate with a moderate, a severe with a severe. Then you randomly select one of that pair to get the antibiotic and the other one gets the placebo. Treat them, and then you compare their differences. So let's say pair one, right? Let's use this pen here. Sorry, guys. So you get pair one, right? And let's see. We'll just randomly call these people, let's say, Todd and Tom. All right. So we randomly select which one of them is going to get the placebo, which one of them is going to get the antibiotic. So using a hat, whatever, Todd gets the placebo. We don't tell him. Tom gets the antibiotic, and we don't tell him either. We treat them, and then at the end, after we treat them, Todd gets his placebo, Tom gets his antibiotic. We check like 2 weeks later. We give them this sinonasal test, and then we measure it. And I'll be honest, I don't know the scale of this, but let's say Todd scores an 8. Tom scores a 10. Then we look at the difference between them. We'll say placebo minus antibiotic is -2. So what we did was we matched them up because let's say they both had moderate. That was their similarity here. You could even match pairs based on other characteristics. Sometimes people will do it based on height. Maybe it could be based on birthday. Maybe you want to match people up who are the same age because you think age might have something to do with it. So you match up, 2 40-year-olds who have sinus infections. Again, randomly select one to get the placebo and one to get the antibiotic. But we would repeat this all the way for 88 pairs. Within each pair, randomly select one to get the placebo, one to get the antibiotic, and then we compare those two individuals. And then we compile all of our results, and then we see what happens, right? You see what happens. You can plot it out on a dot plot. Like in this case, we got, let's see, I'm just going to make it really basic here. We got Tom and Todd, you got about -2. Maybe another pair, when you measure them out, you get like all the way over here, all the way here. And then you plot your differences. Now, if there really isn't a difference between the placebo and your antibiotic, you would expect to see a lot of results right here near zero. That's what you would expect, right? However, if there is a difference between the two, you'd expect to see a lot of your results not near zero. You'd expect them to see them over here. And that's where matched pairs can come in handy, because essentially what you're doing is you're comparing two subjects or two cases that are very similar to each other. Now, another way you can go about with the matched pairs. Now, as I said, you can match up individuals, or another way you can do it in this context. This isn't a great way for this particular case, but can be done in other cases. Say we'll take one of those individuals. We'll take Todd, right? Week 1, we randomly select whether we're going to treat him with a placebo or the antibiotics. We randomly select, pull it out of a hat. Okay, guess what? Todd gets the antibiotic for week 1. And then for week 2, we say, hey, we're going to give him the placebo. And at the end of each week, we measure the rating to see if there's a big difference here. Like, all right, maybe here he gets an 8. Maybe here he gets a 7. The problem with doing it like this, where you're imposing two treatments on one individual, you're randomly selecting the order of the treatments. The problem with this is you're never sure if the treatment is going to be affecting the second treatment. So in this case, maybe the score was lower the second week because, hey, he already took the antibiotic. It's cleared up. Maybe that's the case, right? So, or maybe say it did Tom, right? Or if Tom was our second person, right? When we did it with Tom, we randomly selected, okay, Tom gets the placebo the first week. And then the second week, he gets the antibiotic. And then when you measured it out, okay, when he did the placebo, oh boy, yeah, low score. And then the antibiotic gave him, higher score. He was able to breathe through his nose more. Again, you're not necessarily sure if the fact that he was able to breathe better by that second week was because of the antibiotic, or maybe the fact that his sinus congestion was just naturally clearing up. That's the problem sometimes if you're doing a matched pairs design and that you're basically using the individual as your pair and you're just imposing two treatments. So that's another case of a matched pairs design. But essentially what it is when you're looking at two subjects, you match them up based on characteristics that are very similar, and then you randomly select which one gets which treatment, and then you compare them to each other. Or you take one individual, randomly select the order of treatments, and then see the difference for that one individual. But again, it can have its drawbacks like it did right here. So I did this within the context of our Frappy, and I also wanted to point out, there's a book example where I did a matched pairs design. This is a good one. It's about tires, and they're looking at nitrogen versus oxygen, I believe. And what they did was they took the same exact tire, right? They took a BF Goodrich traction in this case, gave one of them air and the other one nitrogen. Did the same thing for the Bridgestone tire, same exact thing. Two tires that are exactly the same, gave one air, gave one nitrogen. That's a matched pair because you're taking two identical subjects or units here in this case, and you're opposing two different treatments and comparing it. That's a matched pairs design. Whereas with the blocking, as we've talked about a little bit, you take all of your subjects, you break them up based on characteristics, and then after that you randomly assign, and then you're comparing groups in that case. You're comparing, like in this case, we're comparing an entire group of moderate people who took the antibiotic against an entire group of moderate people who took the placebo, and then you're comparing like the average results. That's the difference. You're kind of comparing groups here, whereas with matched pairs, you're comparing individuals. Hopefully that clears up any questions you have about matched pairs design. It's a tough concept. I'll be honest, you don't see it a heck of a lot, but it's good to know when you see it. So hopefully